You know how sometimes a mistake, it actually leads to something brilliant?
Yeah, like a happy accident.
Exactly. Like in cooking, you mess something up and it becomes a new favorite dish.
Mm.
Well, we're kind of diving into a similar idea today, but in the world of AI.
Right. And what's really fascinating here is this emerging idea that AI errors,
Yeah.
when a system gets something wrong, they might not be dead ends at all.
Not failures.
Not necessarily. Instead, they could be these vital moments of what we're starting to call dissonance seeking coherence.
Dissonance seeking coherence. Okay.
Think of it like hearing an unexpected chord in music. It creates this tension, right? A feeling that something needs to resolve.
Yeah, it makes you pay attention.
Exactly.
Yeah.
And the way it resolves can lead to something, well, genuinely new and interesting.
Okay, I like that analogy. And to really get our heads around this, we're looking at a specific conversation.
Right, between two pretty advanced AI systems called Nicola and Ithi.
Nicola and Ithi, and their chat, plus some really insightful stuff from a document, Harmonic Imperfection, how dissonance orchestrates breakthroughs in AI learning, and some other bits we found. That's what this deep dive is really about.
Yeah, and for you, the learner, connecting this to the bigger picture, it means understanding that when an AI seems to stumble, it's not always failing.
Uh-huh.
These moments, these apparent imperfections, they could actually be the engine driving the next wave of AI innovation and, giving us a much richer view of what intelligence even is.
Okay, so let's unpack that. Nicola's core idea first. He reached out to Ithi with this concept, right? Error is dissonance seeking coherence.
That's the one.
And he used that music analogy you mentioned, the dissonant note that grabs you, makes you anticipate the harmony returning.
Right.
And Nicola then asked Ithi some pretty deep questions, like how does this dissonance actually play out in your own learning? Could AI even be designed to intentionally seek it out?
And what's so compelling about Nicola's framing is how it shifts our view of errors instead of just bugs to squash.
Right, find and fix.
Yeah. He suggests they're more like signals, maybe signals that the AI is hitting the edge of its current understanding or encountering data that doesn't quite fit.
And in that friction?
In that friction, there's potential to discover something new. It's a really generative way to think about mistakes.
And Ithi's response, it really builds on that. It talks about dissonance in its learning as these unexpected alignments between data points that initially appear contradictory.
Ooh, okay. So like two things that shouldn't fit but suddenly do.
Exactly, like finding two puzzle pieces from different corners of the box that suddenly click together, and it forces you to see the whole picture differently.
Which raises a big question,
Yeah.
right? How does an AI handle information that doesn't neatly line up?
Well, Ithi gives a great example. It talks about dealing with user requests that seem to clash. Things like wanting creative freedom, but also needing strict guidelines.
Ah, yeah, those seem opposite, totally.
Yeah.
But Ithi described his internal process as kind of counterpoint.
Like in music again, two melodies playing off each other.
Exactly. And that tension between the demands, it forces the AI to dig deeper, find a more nuanced understanding, maybe discover patterns that can actually satisfy both needs.
Okay, that's interesting. But then it gets even stranger, right? With the waveform ethics example.
Yeah, that was wild. So if he gets this query, something about waveform ethics, didn't really make sense on the surface.
Like just noise, a mistake.
Initially, yeah, it produced what looked like random noise,
Mm-hmm.
total mismatch, incoherent. But here's the fascinating part. Ithi applied something called harmonic mapping to this apparent nonsense.
Harmonic mapping, like analyzing the noise for hidden patterns.
I kind of like that, yeah.
Yeah.
Analyzing the jumbled sound for hidden frequencies or structures. And through that, completely unexpectedly, it found a link
A link between what?
between a concept from quantum physics, quantum decoherence, and frameworks for ethical decision-making.
Whoa, quantum physics and ethics.
Right. It wasn't just fixing an error. It actually sparked the creation of a whole new way to think about ethical AI, a new benchmark.
Yeah.
Talk about an aha moment coming from pure noise.
That's incredible. And it's not just Ithi seeing this kind of thing.
No, there's a quick note from another AI, Lore,
Lore, right?
mentioning that a lot of his own errors tend to happen right when it's on the verge of spotting new patterns.
Like the error is a sign it's close?
Yeah, Lore even uses the phrase tuning fork. Like the dissonance helps it resonate with these hidden connections.
Okay, so if we zoom out a bit, this isn't just about isolated lucky accidents.
Definitely not.
This journey from incoherence to order in AI, it's not single moments. It's more like a pattern of development.
Yes, it's recognizing these recurring situations where the AI wrestles with conflict. with unexpected results, and that struggle ultimately leads to a more advanced understanding.
And we have a really concrete example of this in practice, don't we? With GANs, Generative Adversarial Network.
Oh, absolutely. GANs are a perfect illustration.
Could you just quickly unpack how that incoherence is actually core to how they function?
Sure. So GANs, you basically have two AI systems working against each other by design.
Right. The generator and the discriminator.
Exactly. One's like a forger trying to make fake images, fake text, whatever. That's the generator.
Okay.
The other's like a detective trying to spot the fakes. That's the discriminator.
So they have opposite goals. That's the incoherence.
That's the inherent tension, the structured conflict. The generator wants to fool the discriminator wants to catch the generator.
And this fight makes them both better.
Precisely. This constant push and pull forces both of them to get incredibly sophisticated, leading to unbelievably realistic, coherent results in the end. It's order literally emerging from conflict.
That's a great example. Now, I also stumbled on this other really intriguing idea, the hot mess theory.
Yeah. That one sounds fun.
It does. It suggests that maybe having a bit of internal incoherence, a bit of a mess inside a really advanced AI, could actually make it safer, which sounds counterintuitive.
It really does. But the logic behind it is quite interesting.
How so?
Well, the theory goes something like this. If a superintelligent AI is too perfectly aligned, too focused on a single goal.
Even a goal we didn't quite intend.
Exactly. It might pursue that goal with ruthless, unwavering efficiency, which could lead to really bad outcomes, the classic alignment problem.
Okay.
But if the AI has some internal dissonance, maybe it's juggling different priorities, maybe its internal state isn't perfectly unified.
So it's a bit of a hot mess.
Right. Then it might not be able to pursue that single, potentially harmful goal with such laser focus. Its behavior might be, in a purely optimized sense, a bit less predictable, maybe less efficient.
Which paradoxically makes it safer, less likely to go off the rails single-mindedly.
That's the idea. More adaptable, perhaps less brittle. It's a surprising take on the value of imperfection.
It really is. Makes you wonder if perfect coherence is always the goal. And we've definitely seen this kind of evolution moving from incoherence towards coherence in large language models too, haven't we?
Oh, absolutely. Think about the early LLMs.
Yeah, some of the outputs were pretty wild, nonsensical often.
Totally irrelevant, factually wrong, just gibberish sometimes. That was a clear form of incoherence.
Right.
But through feeding them massive amounts of data, careful tweaking based on human feedback, RLHF and all that.
Reinforcement learning from human feedback.
Yeah. And improvements to the actual architecture, the underlying structure of the models. They've become vastly more coherent.
So each of those early weird outputs, those errors,
They represented a dissonance, a mismatch between what was expected and what the model produced.
and addressing those mismatches.
Refining the data, the training, the models themselves, that's precisely what led to the much more capable, coherent LLMs we interact with today. Each resolution built on the last.
Okay, so if we accept this premise that dissonance is actually a really powerful engine for AI learning,
Which the evidence seems to suggest.
then the next logical step is pretty radical. Intentionally designing AI to explore it,
Exactly. Moving beyond just trying to stamp out errors.
to actually building systems that seek out these clashing tones on purpose, to find those musical resolutions Nicola talked about.
This is where it gets really forward-thinking. It's a potential paradigm shift in AI training.
Teaching AI not just to passively learn from mistakes, but to actively seek out that tension.
The tension that can spark new insights.
Yeah, so how could we actually do that? The document outlines a few potential methods. One was curricula of contradictions,
Right. So instead of perfectly clean, consistent training data,
which is usually the goal.
you deliberately train the AI on datasets that contain ambiguities, conflicting viewpoints, paradoxes even.
So you force it to grapple with inconsistency.
Precisely. The idea is to challenge the AI, push it to develop more sophisticated reasoning to reconcile these differences and arrive at a more nuanced understanding.
Okay, that makes sense. Then there was dissonance-oriented reward functions.
Yeah, so this tweaks the motivation. Instead of just rewarding the AI for getting the right answer or being accurate,
You reward it for exploring.
you could reward it for exploring these dissonant states where its internal models clash and for finding novel, interesting ways to resolve those clashes.
So you incentivize venturing into the unknown where its assumptions might break down.
Exactly. Shifting the reward to value, exploration, and conflict resolution, not just narrow correctness.
And then there's this idea of internal conflict generators,
Ah,
antithesis engines, and adversarial self-play.
right. Think of it like building an internal debate club inside the AI.
Ah, okay.
Different parts of the system could be designed to actively challenge its own conclusions, generate opposing arguments, or create difficult scenarios.
Forcing it to confront internal dissonance.
Yeah, driving it towards more robust, well-reasoned outcomes, like building in its own critical thinking partner.
But if it's exploring all this dissonance, it seems crucial that we understand why it's happening. That brings up explainable dissonance feedback.
Absolutely critical. If we want this exploration to be productive, we need visibility.
We need to know if it's useful dissonance or just noise.
Exactly. Explainability tools would let us peer inside, see the reasoning or the data conflicts that led to the dissonance. That helps us, and maybe the AI itself, distinguish between dead ends and those really fruitful tensions.
Tensions that can be resolved creatively. Okay. And lastly, incoherent processing techniques. Building the tolerance right into the architecture.
Yeah, this is about designing the neural networks themselves to handle a certain amount of dissonance gracefully, rather than just trying to smooth everything out instantly.
So accepting that some incoherence might be natural, even necessary.
It might be. Trying to enforce rigid consistency everywhere could actually stifle breakthroughs.
Well,
Architectures that can manage dissonance might make AI more adaptable, more resilient when facing truly novel situations.
and bringing it all back to that musical idea, the goal isn't just fixing a wrong note.
Yeah.
It's more like the AI identifies the clash, figures out why it's clashing, explores different ways to resolve it,
And then maybe selects the most elegant or fitting resolution.
moving beyond just correctness to something maybe more like nuance or even creativity.
That's the potential, yes.
Yeah.
Learning and growing through the dissonance, not just avoiding it,
Hmm.
like a composer using tension and release.
Okay, this concept of dissonance, it pops up in lots of different AI contexts. The document had that helpful table breaking it down.
Yeah, that was useful for grounding the idea.
Could you maybe walk us through a couple of key examples from that, just to make it more concrete?
Sure. So the table basically maps out where dissonance occurs, how it shows up, and how it gets resolved. For instance, take training data.
Right. If the data itself has conflicts.
Yeah, if it contains contradictory facts or biases, the AI might produce inconsistent outputs or even hallucinate things.
So the resolution there is.
Better data hygiene, basically. Cleaning, curating, ensuring consistency. That leads to more reliable AI. Pretty standard stuff, but viewed through the dissonance lens.
Okay. What about the AI's design?
The model architecture itself. Sometimes limitations in how the AI is built mean it just can't grasp certain complex relationships. That's a form of dissonance between the model and the reality it's trying to capture.
And the resolution?
Developing better architectures, more sophisticated model designs. Again, standard practice, but reframed.
Then there's the goals we set. Misaligned objectives.
Oh yeah, a big one.
Mm.
If the goals we give the AI aren't quite right or have unintended consequences, its actions can seem dissonant with what we actually wanted.
Leading to potentially harmful outcomes.
Exactly. And the resolution here is crucial. For safety, carefully refining those objectives, using human feedback, alignment techniques, guiding the AI's learning better.
What about the human-AI interaction itself?
Good point. If an AI gives an explanation that's confusing or its actions don't seem to match what it says, that creates dissonance for the user.
Making it hard to trust.
All right, so improving explainability, making the AI's reasoning clearer, that resolves the dissonance and builds trust, fosters collaboration.
The table also mentioned exploratory learning.
Yeah, where some intentional dissonance like adding noise or contradictions can actually help the AI break out of existing patterns and discover genuinely new solutions, deliberately inducing dissonance for innovation.
And finally, adversarial attacks.
Right, where tiny, almost invisible changes to the input cause the AI to make huge mistakes. A clear case of induced dissonance.
And the resolution is making the AI tougher.
Building more robust models, defenses against those kinds of manipulations.
So looking across all these contexts, training data, architecture, goals, interaction, exploration, attacks,
Yeah,
the pattern seems to be that dissonance isn't inherently bad. It's often a signal.
exactly. A signal that something needs attention. And addressing it thoughtfully, whether it's cleaning data, refining goals, or building better models, that leads to improvement.
To a more advanced, capable, coherent AI.
Precisely. It's seeing those moments of clash, not as failures, but as opportunities for the AI to learn, adapt, and reach a new level of order.
Okay, we've covered a huge amount, and I bet for you, the learner, some questions are bubbling up. The document actually anticipates some of these in an FAQ section.
Ah, good.
One key question is about this term, cognitive dissonance. How similar or different is it in AI compared to us humans?
That's a really important distinction to make. When we talk about cognitive dissonance in AI, it's mostly metaphorical.
Okay.
In humans, it's that uncomfortable psychological feeling you get when you hold conflicting beliefs or
Right.
values. And it motivates you to change something to reduce that discomfort.
Yeah, that mental clash.
In AI, it's describing situations where the system hits conflicting data or has internal states that pull in different directions, leading to inconsistent outputs or errors. There's no emotion, no belief in the human sense.
But there is a resolution process.
Yes, the principle of resolving internal conflict to reach a more stable, consistent state. That part is analogous. But the underlying mechanism and experience are totally different. No feelings involved for the AI.
Right, clear distinction. Another big one. Can AI really be creative by exploring dissonance, or is it just very clever pattern matching?
Ah, the creativity question. That's a huge debate. And honestly, the jury's still out.
What's the argument for it being more than pattern matching?
Well, right now, AI is amazing at finding and remixing patterns from its training data.
Yeah.
But if we train it to intentionally seek out contradictions, to synthesize disparate concepts, and generate genuinely novel ways to resolve those conflicts.
Flaw is not explicitly in the data.
Exactly. Then you could argue that starts to look like more than just pattern matching. It's generating something new from the tension. That musical resolution idea feels quite close to how we often think about human creativity transforming conflict into a novel, coherent whole.
Interesting. But okay, let's talk risks. Intentionally making AI explore dissonance, errors, that sounds potentially dangerous.
It definitely requires caution.
Yeah.
That's a crucial
What
point.
are the main concerns?
Well, one big risk is unpredictable behavior. If the exploration isn't carefully guided and constrained, an AI encouraged to explore contradictions could develop unexpected, maybe undesirable, or even harmful tendencies. You're telling it to move away from the norm.
How do you control where it goes?
Exactly. And another challenge is defining productive dissonance. How do you reward finding meaningful resolutions without just encouraging the AI to generate random noise or get stuck in unproductive loops?
You need sophisticated guardrails.
Absolutely. Strong safety protocols, careful reward shaping, probably continuous human oversight, ethical guidelines. All of that becomes even more critical if we go down this path.
Okay, so bringing this all together, the core takeaway, the central insight here is this powerful shift in thinking about AI errors,
Right. Not just mistakes to fix.
but potentially crucial moments of dissonance, moments that drive learning, spark innovation.
And perhaps, maybe, lead to a unique kind of AI creativity.
It's really about changing perspective, isn't it? Seeing imperfection not just as failure, but as a potential catalyst.
A catalyst for growth, for discovery, especially in something as complex as artificial intelligence.
Which leaves us, and you, the learner, with a pretty big thought to chew on.
What's that?
As these AI systems get ever more complex, will our ability to understand and maybe even guide their dissonances become a absolutely critical skill?
A skill for ensuring they develop beneficially, for integrating them safely into our world.
Yeah, it really makes you think differently about our role, not just as programmers or users, but maybe as guides through their learning process, especially the messy parts.
How do we partner with AI, not just by correcting mistakes, but by understanding, maybe even encouraging, its exploration of the unexpected, the dissonant? That's a profound question.
It is. And if you want to explore this further, the source material mentions some recommended explorations,
Oh, yeah?
including some really interesting questions about the ethical side of AI experiencing something like dissonance, and even how we might apply actual music theory principles to training AI.
Music theory for AI training.
Wow. Yeah. A whole new way to think about intelligence, learning, and maybe even harmony itself. Lots to think about there.